Ever wondered why the Euclidean theorem matters so much in our daily lives? This foundational principle of geometry, named after the ancient Greek mathematician Euclid, has an unbelievable range of applications. From the design of the buildings you see around you, to the routes your GPS suggests, even to the calculations that put astronauts into space, the Euclidean theorem is silently at work. Intrigued? Good, because we're about to delve deep. Stay tuned to understand the magic behind this fundamental mathematical principle. The Euclidean theorem, named after the ancient Greek mathematician Euclid, is a simple yet profound concept. Now let's break this down. Imagine a right-angled triangle. This triangle has one angle that is exactly 90 degrees, which we call a right angle. The side opposite this right angle is the longest side of the triangle, which we call the hypotenuse. Now, here's where the magic happens. The Euclidean theorem tells us that if we square the length of the hypotenuse, that is, if we multiply the length of the hypotenuse by itself, the result will be equal to the sum of the squares of the lengths of the other two sides. Think of it this way. If you were to create a square with each of the sides of the triangle, the area of the square formed by the hypotenuse would be equal to the combined areas of the squares formed by the other two sides. Let's bring this concept to life with a real-world example. Suppose you're building a fence diagonally across your backyard. The distance from one corner of your yard to the other along the fence represents the hypotenuse of a right-angled triangle. The other two sides of the triangle are the widths of your yard. According to the Euclidean theorem, if you were to square the length of your fence and add up the squares of the widths of your yard, those two amounts would be equal. This theorem isn't just about fences, though. It's a fundamental principle in architecture, navigation, engineering, and even computer graphics. Anytime you need to calculate a straight line distance in a flat plane or space, the Euclidean theorem is your go-to tool. This theorem is a cornerstone of geometry, underpinning many of the concepts we take for granted today. It's like a secret key that unlocks a world of understanding, helping us to make sense of the space around us. Whether we're navigating city streets or designing skyscrapers, the Euclidean theorem is there, quietly guiding our calculations and shaping our world. You might be wondering, where do we see the Euclidean theorem at work in our daily lives? Well, the answer is pretty much everywhere, in ways you may not even realize. Let's start with architecture. Architects use the Euclidean theorem to determine the shortest path to construct roads, bridges, and buildings. This helps in efficient planning and utilization of resources. In fact, the Pythagorean theorem, a special case of the Euclidean theorem, is used to ensure that buildings are square and symmetrical. Moving on to the realm of physics. Here, the theorem helps calculate distances. For instance, when astronomers measure the distance between celestial bodies, or when physicists calculate the trajectory of a moving object, they're using the Euclidean theorem. It's essentially a universal measuring tape. Now, if you've ever used a GPS to find your way to a new location, you've indirectly used the Euclidean theorem. The system calculates the shortest path between 2 points on a map, providing you with the fastest route to your destination. In the world of computer science, the theorem is used in machine learning algorithms to calculate the distance between points in a multidimensional space. This aids in the classification of different data points, and ultimately in making accurate predictions. And for those of you who love video games and digital art, you'll be interested to know that the Euclidean theorem plays a key role in computer graphics. It's used to calculate the distance between pixels on a screen, allowing for the creation of smooth, lifelike images. Even in the field of music, the theorem is at play. It helps in determining the pitch and frequency of sounds, allowing musicians and sound engineers to create harmonic tunes. So the next time you use a GPS, play a video game, or even listen to your favorite song, remember that the Euclidean theorem is silently at work. As you can see, this seemingly simple theorem has far-reaching implications and uses in our world. So, we've dived into the world of Euclidean theorem, but what are the key takeaways from our journey? We've walked through the path laid out by the ancient Greek mathematician Euclid, uncovering the core principle of his theorem. The theorem, which is as simple as it is profound, asserts that in a right-angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. This principle, although dating back to over 2,000 years ago, has maintained its relevance in modern mathematics and physics. We've also seen how the Euclidean theorem is not just an abstract concept confined to the world of mathematics. It permeates our daily life, appearing in surprising places like GPS navigation and computer graphics. It's fascinating to think that an ancient mathematical principle still has such profound implications in our technologically advanced age. Moreover, the Euclidean theorem's importance extends beyond these practical applications. It's a shining example of how elementary concepts can lead to profound insights, inspiring us to look for simplicity amidst complexity. In many fields, from architecture to astronomy, it serves as a foundational tool, underpinning the structures and phenomena that shape our world. Remember, even the most complex concepts often have simple foundations, just like the Euclidean theorem. Keep exploring, keep learning, and you'll uncover the fascinating truths that shape our world.